Assalamualaikum warahmatullahi wabarakatuh. My name is Syuhadah binti Zakaria, and I would like to present Soil Water Characteristic Curve SWCC of Lime-Laterite Stabilized Soil as a Clay Liner Design. The content of my presentation would be problem statement, introduction, literature review, timeline testing, result and discussion, and lastly, conclusion. The problem statement of this research would be, according to Fauzia and Agamutu, 2012, there are approximately 30,000 tons of municipal waste have been filled up Malaysia's open landfill due to the growth of population. Those cases affected the increment of leachate produced due to the infiltration of rainwater through landfill that contaminate the groundwater with some dissolved particles such as heavy metal and microplastic. This issue will surely endanger human health and pollute the environment. Thus, Lime-Laterite stabilized soil has been chosen to test its compatibility for it to be used as a lining system that acts as a hydraulic barrier. Laterite soil, which also known as residual soil, are mainly distributed in Malaysia due to the weathering process of tropical rock, which located and laid above the groundwater table that in unsaturated zone. Due to its location, the lining system, which is lime-laterite stabilized clay liner, need to be designed under unsaturated condition which acknowledge the importance of unsaturated cell behavior that involve suctionability in order to analyze the soil water characteristic curve SWCC. Based on ASTM D6836-16, there are four main methods of SWCC, which are first hanging column method. This method is used for only coarse soil, and the suction range used is from 0 to 80 kPa. Second is chill mirror hygrometer. The suction range used is from 1000 kPa to 100 MPa. This is due to the SWCC near saturation is not needed. Third is the laboratory bench centrifuge. This is for coarse soil only, and the suction range is from 0 to 120 kPa by varying the angular velocity of centrifuge. Lastly, pressure plate extractor. This method uses volumetric and gravimetric water content measurement, and the suction range used is from 0 to 1500 kPa based on the ceramic plate. And for this research, we will be use pressure plate extractor. This is the timeline to conduct the study. Firstly, the laterite soil was collected at P16 in UTM Skudai. The soil was transported to the geotechnic lab to run several basic testing such as particle size distribution, standard Proctor compaction, Atterberg limit, initial consumption lime, and unconfined compressive strength. After all basic testing was done, I proceed to do the SWCC process using pressure plate extractor. The suction range used was from 0.1 to 900 kPa according to the ability of pressure plate in the geotechnic lab. The result of SWCC then fitted into Fredland and Zinc 1994 and Van Kenischen 1980 to get the SWCC parameter, which are A and M and theta S using the volumetric water content measurement. The result then extended from 1000 kPa to 100 MPa by using the formula of both modules. After that, the calculated correction factor was multiplied to fit the Fredland and Zinc 1994 to fit the SWCC for 0 water content in 100 MPa. Then, all results will be gathered and discussion will be made. is the experimental result that obtained from the pressure plate extractor. As in the slide, metric suction is from 0.1 to 900 kPa. 0.1 kPa is considered as the saturation state in this study. This is the log graph that fit using the Fredland enzyme 1994 model. Next is the parameters of the Fredland enzymes 1994. As you can see in the slide, the value of A, N, and AEV increases in addition of the lime content, while the saturated volumetric water content, which is theta S, decreases as the lime content increases. This is the log graph that fit using Van Genuchen 1980 model. Next is the parameters of Van Genuchen 1980. As you can see in the slide, the saturated volumetric water content decreases as the lime content increases, while the AEV, which is A entry value, increases in addition of lime content. Next is the correction or modified Fredland enzyme 1994 fitting. This is the log graph that shows the modified Fredland enzyme 1994. Delta S, or saturated volumetric water content, trend decreases with the addition of lime content. Thus, the SWCC of stabilized sample indicate more water content for treated laterite soil in the same section. The AEV or A entry value for both models increased from 80 kPa to 200 kPa for untreated, 3%, 5%, and 7% of lime content respectively. Hence, this case shows that the water infiltration and flow can be delayed. Lastly, the parameters A and N, which is pore size distribution related to the AEV. As the percentage of lime increases, so does the A and N value. This increment also indicates the size of soil pores getting smaller. Thus, the higher the lime content, the higher the metric suction needed to eliminate water from the soil pore. As referred to the discussion before, this study concludes that Lime-Laterite stabilized soil is compatible to be used as a clay liner design due to the experimental results that have been discussed. The SWCC result obtained can be applied to calculate unsaturated hydraulic conductivity, shear strength, and numerical modeling of unsaturated Lime-Laterite stabilized soil. The recommendations of this research are: first, the experiment can be improved by extend the graph from 1000 kPa to 100 MPa using filter paper technique or Cheung mirror hygrometer. Secondly, the SWCC studies can be expanded by doing both wetting and drying path to gain more analysis and knowledge on hysteresis of SWCC. That's all from me. Thank you.